All right, IM1 4.2, graphing inequalities with two variables. Let's start off by just thinking about what a solution is to an inequality, okay? So let's take a look at this first question. It just says, is 4, 3 a solution? Well, remember, this is just an x and a y. And so what happens if you were to plug in said x and said y? Well, for x, we're going to plug in a 4. And for y, we're going to plug in that 3. And we're just going to say, do these values work in this inequality? Well, 2 times 4 is 8. 8 minus 3 is 5. Is 5 less than 4? It is not. So we would say, no, this is not a solution. Because if it was a solution, then this inequality would stay true, okay? There are lots of solutions to this, infinite actually, but this is not one of them. This point right here is not one of them. So let's try this next one. Go ahead and just try this one on your own. Tell me if you think this is a solution or not. Pause the video and then unpause it when you're ready to check your work. All right, now maybe this is a little tricky for you because you might have thought, oh yeah, 0, 0, that works. But it doesn't say or equal to. What this is like saying that 0 is actually less than 0. And that doesn't make any sense, right? A number cannot be less than itself. Now, if I was to put a little line there, then that would be okay. But it's not there. So we'll have to just say no, there's no solution here. All right? Let's go on to the next problem here. Let's talk about how we can graph a linear equality. There's a few steps I want you to take when it comes to graphing a linear equality. The first thing that I want you to do is convert or change to slope-intercept form. So that'll look something like this. Either y is less than or greater than mx plus b. And it could be equal, right? It could also be or equal to. This symbol, this could be lots of different things. But basically, we want the y over here, and we want the mx plus b. So that's step one. Our inequality here is already in that form. So we're good. We could go ahead and go on to step two. Step two is to simply graph the graph inequality like a line, except for one thing we have to keep in mind. If we have a less than or a greater than, that's greater than less than, without the or equal to symbol, then that's going to be a dashed line when you graph it. And if you had something like this, greater than or less than or equal to, right? If you add that little or equal to there, then that's going to be a solid line. All right, but that's okay. We'll get the hang of this. This one is or equal to, so I'm going to do a solid line here. So I'm going to start off at -3, right there. And my slope, you can see right here, my slope is -1, and my y-intercept, or my b, is -3. That's why I started at -3, and my slope is -1, so I'm just simply going to go down 1 over 1, down 1 over 1. And that also means that I could go back 1, up 1, back 1, up 1, back 1, up 1, and so on. And then if I was to connect all these dots with a solid line, not a dashed one, again, because it's or equal to, basically, like the simple way is like if there's a little line underneath, it's a solid line. If there's not a little line underneath, it's going to be a dashed line here. All right. All right, we've graphed the inequality line. Now, there's one last step, and that is to shade the correct area. Shade the correct area. Well, here's the beauty of it being in slope-intercept form. If you have y is greater than, you're going to shade up. And the easy way you could think of that is, well, y is bigger, so this is where y is bigger than this line. If you have y is less than, you're going to shade down. So in this equation, we have y is less than, so that tells me that I need to shade down. So what does that mean? That means that any point along this line is a solution, as well as any point below this line is also a solution. And that's why we have to shade it, because it's not just a line anymore. It's all of these points work in this inequality. Okay, so let's see another one. All right, we have this problem here, and the reality is we actually do know how to graph this. We've done this before with this form. This is called standard form, and you could cover up the x and solve for the y-intercept, or cover up the y, because if you plug in a 0 there, it'll just turn to 0, and solve for the x-intercept. But the problem is you're going to get an x-intercept of -20, and that's not going to fit on your graph. It's going to be like way over here. So it's not going to be very useful. So let's follow our steps. Let's follow our steps of getting it into the correct form, which is slope-intercept form, right? We want it to look something like this. So step one I would do is subtract x from both sides. I'm going to do the work over here off to the side. I would end up with 4y is greater than -x minus 20. And I like to put the x first just because that's how it goes in slope-intercept form. Next step is to divide both sides by 4. When you divide both sides, you need to divide everything by 4. These cancel. So you get y is greater than -1/4 x, and then 20 divided by 4 is 5, so this is going to be -5. All right, there's step one. Step two is actually just to graph this line, but the thing we have to keep in mind now, there is no line underneath here, so this is going to be a dashed line. So let's go to our y-intercept of -5. Then let's think about our slope being down 1/4, down 1/4, which also means I could go up 1, back 4. And I'm going to connect these dots, but I'm going to connect it with a dashed line to show that it's not equal to at that line. My line looks a little crooked here, so forgive me. Let's see if I can fix that real quick. All right, that looks a little better. All right, and the last step is we're going to shade the correct area, and now it says that y is bigger than, right? Y is bigger than, so that tells me I'm going to shade up. Now, I want to show you another thing that you could do to check this. Another way is, it's called, to figure out where to shade, you can just use a point. Oops, wanted to do. And the best point to use when you can is the point 0, 0. So we're going to use the point 0, 0, and we're going to check it in this equation. And you could check it in this one, or you could check it in this original one. I'm going to check it in this original one. So let me show you what I mean. I'm going to plug a 0 in for x. Then plus 4, plug a 0 in for y. And then greater than -20. And I'm just going to check if this is true. If this is true, that means 0, 0 is a point over here, and that means I've shaded in the correct area. If it's not true, then I have shaded in the wrong area. So let's double check. Well, 0 is just 0. 4 times 0 is 0. Is 0 greater than -20? Well, yeah, it is. It absolutely is. So this is true. Therefore, my point is in the correct spot, so I did shade in the correct area. All right, we got another problem right here for you. I want you to try this one on your own. So just pause the video, give it a try, and then check back when you're ready to check your work. Okay, it's already in slope-intercept form, so I went ahead and graphed the intercept of 1. I have a slope of -6/5, so I just went down 6 and over 5 to get another point. Simply connect the dots. You get this line right here, but remember, it is not or equal to, so I have to do dashed. Then I can simply tell that y is less than, so I'm going to go down from this graph. And simple as that. I could also pick the point 0, 0 to plug in here, and I'd end up with 0 is less than 1. So yeah, 0, 0 works, so I have definitely shaded on the correct side. Okay. All right, just a little reminder here. This is really important that you understand this. Then it's just saying if y is greater than mx plus b, or y is greater than or equal to mx plus b, that's when you're going to shade up. And if it's less than, that's when you're going to shade down. Now, this only works when the y is all by itself, right? The y has to be all by itself for this to work. So know that. That's why we converted to slope-intercept form, so we don't have to worry about it being in the wrong format. All right, let's go to the next page. All right, we got a word problem. Oh no, a word problem. It's the worst ever. Nah, it's going to be simple. You'll see. So Mr. Kelly and Mr. Brust are raising funds for a big trip to Graceland. They must be Elvis fans. Mr. Kelly makes about $15 for every hour he works, and Mr. Brust makes about $5 for every hour he works. Man, I think that's below minimum wage now, federal minimum wage. They figure they need to take at least $100 to go. Or to make, sorry, not take, make at least $100 to go. Well, this phrase right here tells me a lot. I'm going to underline this. At least $100. That means at the end of the day, whatever I do, it must be greater than or equal to 100, right? The total amount that I make between Mr. Kelly and Mr. Brest has to be greater than $100. By the way, it's going to cost way more than $100 to go. This is like, must be an old problem. All right. But what else do I know? Well, if Kelly makes $15 an hour and Brest makes $5 an hour, I could say something like, well, the amount, let's do this. Let's define our variables. We're going to use X. Now, you could use K and B, but we're going to say X, just because that's what we're used to, is Kelly's hours of work. And we're going to say that Y is Brest's hours of work. And it's a good idea to define your variables because it just helps you know what you're talking about. Well, what does that mean? Well, that would mean then that if I had $15 for every X, right, for every hour that Kelly works. So if I had 1 hour, I'd have $15. If I had 2 hours, I'd have $30, and so on. Plus 5 for every Y, every hour that Brest works. I would have the total amount of money that they're going to make, which we already said has to be at least $100. Now, at least tells me it's greater than $100, or it could be equal to. That's how I knew that would be equal to. All right, I have an inequality, but now they want me to graph it. Well, before I graph it, I don't really like it in this form. Again, you could use the intercepts, but then it's a little bit tricky to find out which side to shade. You'd have to plug in a 0 and a 0 to like see if you're on the right side. Again, very doable. You could do it that way if you prefer, but let's just go to slope-intercept form. So for slope-intercept form, I'm going to subtract 15x, subtract 15x. I end up with 5y greater than or equal to negative 15x plus 100. Divide both sides by 5, which means I divide everything by 5. So I end up with y is greater than or equal to negative 3x, because 15 divided by 5 is 3, or negative 3 here. And then 100 divided by 5 is 20. All right, that's going to be pretty easy for us to graph now, because I have a y-intercept of 20, and I have a slope of negative 3. So I'm just going to go down 3 over 1. Boom, boom, boom. And it's or equal to, so that means I can make it a solid line. Boom, boom. And it says greater than, so that tells me I'm going to shade on the upside of this graph. And that actually makes sense if you think about the context of the problem, right? They want to make at least $100. These are all the points along this line are all the points where we would make exactly $100. And everything over here is where we'd make more than $100. And it's definitely okay to make more than $100, right? There you go. Okay. There's a problem. I have another problem here for you. I want you to try this on your own again, but a couple hints. Remember, convert this to slope-intercept form first, and it'll make your life a lot easier. It's going to be hard to find the intercepts here if you were to try to do this standard form way, because if you plug a 0 in here, that disappears, and you'd have to divide both sides by 5, and negative 12 divided by 5 is going to give you a fraction, and fractions are hard to find a specific point. So I think you're better off using the slope-intercept form. So go ahead and try this one, and then check back when you're ready to check your work. Okay, so a couple things here. When you convert it, I subtract 5x, and then from there, I divide everything by 4. So you're going to get this fraction, negative 5/4 as your slope, and this y-intercept of negative 3. So I plotted that. And then from here, I want to go down 5 over 4, but you see that gets me off the graph. So I can do the exact opposite. I can go up 5 and back 4. That's fine. That's the exact opposite of going down 5 over 4. And so I found this point here, connected those dots to make my line. I knew it was a solid line because I have this or equal to symbol here. And then after I get it, the y all by itself, I'm able to see that its y is less than, so I knew I need to shade downwards. Simple as that. Now, you could also plug in the point 0, 0. If you plug in a 0 here and a 0 here, you're going to end up with the point 0 is less than or equal to negative 3. And that is not true. So you shouldn't shade where 0, 0 is. And we already knew that. So we're good. Okay. That's it for this video. I'll see you guys on the next one.